Okay, thank you. Welcome everyone to our second live session in our course CVS VLSI design. Uh, but this session is primarily targeted for, I think, okay, I think there are some repetition. So yeah, please let's start now. So this how do I stop this channel mute? I think it's clear. Acha, yeah, yeah. Okay, okay, yeah. So as I mentioned, the primary objective of this session to answer your questions. Oh, okay. Now it is fine. Sorry. So let's. Sorry for the interruption. Uh, our objective is to discuss the questions you have. This live session is basically meant for you. So please feel free to ask questions, and I'll be happy to answer any questions you have. Right. Uh, in general, this is not where I am going to teach anything. It is basically for having clearing you have any doubts, anything about the course or around the course, anything we can discuss, right? So please feel free to put your questions in the chat, and I'll be happy to answer any questions you have. So I'll wait for your questions. In general, I think we are now in 8th week of the course. We have already completed. Uh, I think this is 7 weeks running, and 8th week will start next week. Then we are already completed kind of 2/3 of the course, right? We have, I think this the first half was on the basic theory background, the background theory, which will be used at the back end of the tool to do the high-level synthesis. But I think the most interesting session is for the 7, 8, 9 this weeks, because this is where we basically talk about developing an efficient hardware through HLS, right? So what kind of optimization you can use, what kind of optimization available in the tool, and what is the impact of each optimizations, and which context you should use, right? If you want to do delay minimization, what you should do. If you want to do area minimization, what you should do, or say for latency, what should do. So all these things is being discussed in the course in this particular week, and I think this is very important to understand. And effectively, we need to use this strategy that we have been taught in the class now this week's will be very useful to develop any efficient hardware through high-level synthesis, right? So please put your effort understanding the theories, and feel free to put questions in the group so that you have any questions, we'll be happy to clarify and answer your questions, right? To help you further, this year we have added 2 more videos. In this, while I actually give a demo of the high-level synthesis tool Vivado HLS, which we have 2 demos effectively. The first demo we have shown how do you do the high-level synthesis with Vivado HLS, how to check the correctness of the input C code, how to write the test bench, how do you do the high-level synthesis, how do and then check the correctness of the Verilog that is generated by high-level synthesis, right? So all these things has been discussed in this the video 1. And in the video 2, which we have shown that how do you apply the optimizations, how do you put the optimization of the high level synthesis using Pragma in your code so that you get different results. So I basically took one example and I generate the baseline in implementation without any optimization, and then I keep applying different optimizations, and I have seen what is the change in the latency area and others, right? And through which I try to emphasize that how effectively you can utilize the optimization that are available in the tool, right? I think these two particular uh, video is very useful, and please go through them, install the tool, you try yourself, because just knowing the theory won't help you to do it practically, to use the tool effectively. You must download the tool and use it, right? So then only level to learn more, and your learning will be useful. See, for example, when I teach this course here in IIT Guwahati, I always give course project, and in the course project, I ask every student to install the tool, and I give certain project where I ask them to take some image applications, image processing applications, or maybe cryptographic applications, or it may be post-quantum applications. It can be ML application, and ask them to do HLS, right? And generate Verilog and simulate and see what is the performance, and then apply all the optimizations, right? And then you see where is the benefit, whether you are getting the benefits or not. So what I'm trying to suggest is that if you do that exercise, automatically learn more, and that will help you to. Uh, uh, so that will actually be very helpful for you, and you can utilize the tool for your research, course project, for your higher so MTP project, BT project, right? If you are doing similar kind of work. So yeah, that's all from my side for today. So I'll be waiting for questions from your side. And if there is no many questions, we'll conclude. So please ask questions if you have any. Uh, I'll not extend the session for 1 hour if there is no further question, right? I've already mentioned about the things that you should concentrate in studies, and you are going through the most crucial weeks of this course. 7, 8, 9 is the most crucial week in this course. So please learn the subject, install the tool, try yourself, right? That will make you ready for this kind of research. So please, do you have any question? Let me see if there are any questions was in the earlier slide. No, as such, there is no question. So apparently there is no question today for the students. So uh, yeah, so there is first question came. One thing I want to suggest, practice few questions do the assignments well. Try to do the similar kind of question practice yourself. Otherwise, what will happen that you may not able to do well in the exam, right? So I have given at least 25% of the questions directly from the assignments. So if you do well the assignments, you'll able to solve those questions, similar questions in NSEM as well, right? And also there are quite few questions which actually follow directly from the slides. So attending the slides, uh, I mean, course video lectures well will help you better, right? But at the end of the day, you need to solve few new questions as well, right? So I'll give you certain scheduling DAG or sequence graph, and then I'll ask you to apply this scheduling to this and do the scheduling of that graph, and you there'll be few questions on that, right? There'll be few questions on how the register allocation of a particular design. Uh, I mean, based on the scheduling information and so on, right? So I mean, everything will be aligned to what we have been taught in the class. There will be nothing which we are not covering in the class. So practicing few similar to what we have given in assignments will make you ready for the end and to perform better. Okay. So there is one question from Divyan. What he's saying, what are the other language other than C that we can use and do HLS? So C++ definitely yes. This Vivada HLS tool, it can take C or C++. Also, there are few tools which can even give you Python code directly, right? For example, there is a tool called HLS for ML. I'll type the things. I can actually give you the link also. Which is basically targeting this machine learning hardware. So I'll give you the link as well. So this is where you can use Python code also, right? Your ML model, which is a trained model, and you can generate the Verilog for those models directly, right? So primarily C++, and this kind of open source tool, even Python, you can take. There are also other commercial tool like SMC Symphony Model Compiler, which can take even Simulink design, right? Or MATLAB code. I mean, but that is not free. So Symphony Model Compiler is Synopsys tool, which is if you have license only you can use, right? I can give the link, but I think that is not free for everybody. But anyway, if you do C++, Python, that is I think more than enough, right? Thank you. Is there any other questions you have? Okay, let's see. Is there any other questions? Not much, not many. I think people are happy with the codes. They don't have further queries here, which is easier for me. But prepare well for the NSEM because NSEM has 75% weightage, right? If you want to perform well in this course, you need to prepare well for the NSEM, right? These assignments have 25% weightage, but effectively more weightage is on the end semester examination, right? And as I mentioned, many you need to solve problems. I have not given all questions text-based, right? Because if you see the way I have taught in the class, I take examples and solve it, right? So expect a few questions on the similar trend that take some example, do scheduling, do allocation binding, right? And it will, and then you answer few questions then. right? So similar questions you should expect in the end semester as well. Okay. Yeah. Please feel free to put questions because without the question, this live session has no meaning. Uh, if I keep speaking, that is not the purpose of this. Uh, uh, okay, so I'll give. I have actually recorded the one video on how to use the tool, and that will be available in next week, in week 8. Okay. So I have recorded 2 videos. One video to the tool is Viva HLS. I'll give you the link also, which basically which become GTS now, the most recent version, but code is basically same, right? So uh, I'll give you the link also. So please attend that video that I have. Uh, uh, please see the video where I actually give the demo of the tool. So that will give you very much idea that how to utilize the tool, right? The Synopsys tool name is Symphony Model Compiler, which is called SMC. I'll give you the link also. But that is actually I work on that tool when I was in Synopsys. So many of the code base was developed by me for that tool. Just a second, I'll identify. I think it's now acquired by Microchip, looks like. Earlier it was Synopsys. So I'll put that. But this is basically for a Simulink design. So when you basically drag and drop and create a diagram with all the uh, blocks you have in the Simulink model library, right? And then this tool take that and generate RTL from that. So this is something, another tool, if you have access, you can try that. It's basically easier to convert your MATLAB Simulink design into RTL, right? People who are working on Simulink side, that will be useful. But Vivato HLS is the tool which is something is more useful, and my course is more tuned towards the Vivato HLS or VTS, right? So that's something the course is designed like that. Okay. Divyang has one more question is um, in VLSI design, when should we prefer static memory allocation over dynamic for hardware register buffers? Does this impact synthesis and timing process? So effectively, it's a good important question, Divyang, but unfortunately, you cannot have a variable or dynamic memory in hardware, right? So when you have a IC in your computer or in your, say, mobile phone or in your smartwatch, your memory is fixed, right? It may be 2 GB, 500 GB, 1 TB, whatever it is, but the memory is fixed, right? You cannot change the memory, right? So that is why all this dynamic memory allocation is not supported in high level synthesis. So you have to have a very static size of memory. You have to know that what is the highest level of data you need for doing something, and you have to allocate memory according to that, right? So you cannot do high level synthesis when you have malloc, calloc, this kind of things in your C, because it's good that if you run the program one time with, say, suppose you're doing sorting, right? So you can run the sorting algorithm with 10 data, it will sort 10 elements. Next time you sort with 500 data, it will sort for 500 elements. But in hardware, you cannot have this. You think about your computer, desktop. Memory can be changed. Your cache size is fixed, right? Cache memory is fixed. Your hard disk is fixed. RAM size, everything is fixed, right? So same thing in IC also. In IC, it's more strict, right? You already have a fixed layout where you know how much memory is there. So you cannot do that. So what is the way out? If I ask you, that you decide what is the maximum memory you need and you allocate that much, right? But it is a static memory. Okay. Uh, I think that answered your question, Divya. But it's an important question. Many people make a mistake here. And then Aditya Sekhar has one question. So the heuristic algorithm does not guarantee the best solution always. So how do we tackle such situation in adapting the process in coming future? Yeah, again, it's a very important question, and you have observed correctly. The heuristic solution is good algorithm. So if you see this high-level synthesis scheduling problem is NP-complete problem, and allocation binding is also an NP-complete problem, right? So the problem with NP-complete problem is that these problems are complex in nature, in the sense, if you want to get the optimal solution or the best solution, your algorithm should be exponential, right? You think about your in a scheduling perspective, if there are n nodes in your graph, the best solution will be maybe 2 to the power n, right? That will give you the best scheduling algorithm. But that is not practical, because it will take a lot of time, and your tool nobody will use. Even for scheduling, your tool probably take 1 hour, right? So that's why what is the way out is the heuristic. The heuristic is not random, right? Heuristic is a very well thought idea, right? For example, if you think about the list scheduling algorithm, what we take the heuristic that the criticality node is the distance from the last node or the end node. So then if some node is very far from the end node, that means that has to be scheduled first, because there are so many nodes depends on that. Unless you schedule that node, the node that depends on that particular node will cannot be scheduled, right? So as a result, this is a good heuristic, right? So, but there may be some scenario where this won't give you the best results. So, but the problem is that the NP-complete problem, the exponential algorithm, will take too much of time, right? On the other hand, the heuristic algorithms are much faster, and they can give you a result in maybe n order of n, or order of n log n, or order of n square, which is much quicker algorithm. But if we guarantee that it gives best solution in 90% of the time, and some cases it gives solution which is maybe 5-10% worse than the actual solution, it is good, because earlier it was taking maybe 10 hours to run, it's just taking 10 seconds to run, right? So it's kind of a trade-off between the quality of results and the runtime. And when you take a small design, you don't see the difference. But when you go to industrial design, sometimes even synthesis take 2 days, right? Just to synthesize and generating the very log. So uh, in this case, what will happen that uh, if you do not make your runtime reasonably small, nobody will use your tool, right? Because it's, I mean, if you just synthesis, it's not actually just synthesis once and your design is ready. There may be some violation of timing, some your area is not, your design is not fitting into the target device. You have to do the things multiple times, right? And every time it is taking 2 days, 3 days, then you're gone, right? So that's why uh, this heuristic solution are being used everywhere in the synthesis flow. It's not only in high level synthesis, in logic synthesis, physical synthesis, every places, all algorithms are heuristic based solution, right? So this is something uh, what is there in the state of the art, but in the kind of area where I am all working, and kind of there is a lot of focus. And if you're a research scholar, that can be a good area to start, that how machine learning can technique can help in this kind of problems, right? And we are working on those areas. Okay, so think about the scheduling, right? Scheduling, we have this priority function, which is the distance from the link node, sorry, the sync node. Now, how about you develop a machine learning algorithm that will effectively give you the priority value for a given node? So if you give a DAG, if you tell this is the node, what is the priority? It will give you priorities 1, 2, and so on, right? So this way, machine learning, or you can think about a reinforcement learning based algorithm that will do your scheduling automatically, right? It will give you the schedule behavior. Given an input tag, it will give you the schedule, right? So this is where machine learning technique can also help you in this process. Similarly, if you go a little bit the lower synthesis steps like logic synthesis or physical synthesis, so they are actually going to predict the delay of a design, predict the power of a design, predict the area of a design. So and now you can take a decision whether I'll apply these optimizations or not, right? If the power, say, if your area became too high after applying this optimization, so I'm not going to apply that optimization, right? So this way, so effectively, I think the domain where a lot of people are working is called ML for EDA. Is like you rethink the problem of scheduling, allocation, binding, logic synthesis, physical synthesis. In the physical synthesis, routing, placement, partitioning. Can machine learning based predictions or regression models can help you in uh, 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 improving those tools, right? So effectively, think of heuristic also giving you uh, some information, right? So for example, during the criticality, so if you your heuristic is saying that you take the distance from the sync node to the node as the parity function. How about I use ML and give you the parity value and I use that value in scheduling, right? So same thing. So instead of a heuristic approach, which is kind of logical in most of the sense, how about a data-driven approach, right? If you have 10,000 schedule graph, and from there you learn a model and it can actually tell that among this node should be scheduled first, right? So this is the kind of domain where a lot of people are working, and I mean I have two PhD students working on the similar areas. So if you are a research scholar, you can think about the redesigning the machine learning, sorry, EDA algorithms with the help of machine learning algorithm. Okay. Yeah. So this is one domain. I think is there any other questions here? Uh, yeah, Divyang has one more questions. Obviously, I'll take any questions you ask here. What are the most other-friendly data structure in C for VLSI? So it's a little bit abstract question, I would say, but uh, it has meaning. It's so, for example, the main bottleneck comes from a software and hardware perspective is the memory access, right? In hardware, memory access is not free. It takes one clock. Right. So when you think about a program where, say, you are accessing an array uh, multiple times, uh, and now if you think about in hardware, uh, in C code, when you write, you don't care about how many times you're reading the value, right? You think about it's okay, I can read multiple times. But if the data is same, suppose you are accessing location 5, A5, if you are in and here there is a loop and probably you are accessing this value 10 times in the loop. When I write the C code, we never bother about how many times I'm reading the same value multiple times, right? But in hardware, every time you read from the memory, that array map to memory RAM, it will take one clock, right? So the memory access, if you can reduce, right? You can rewrite your program so that you can reduce the memory access, it will be helpful, right? So I have given few examples in the, I think week 8 or where I can rewrite the code so that the data which is reading multiple times, instead of reading multiple times from the memory, you read it once and stored locally in a register, right? So you don't need to read multiple times because if you read it once, you can store locally and use it whenever it's needed. So that way you can actually reduce all the memory access. So this memory access is one of the bottleneck which we write when you write C code, we never bother about. But when you execute the same behavior in hardware, we have to think about that part. And if you make sure that you are not you are removing all the redundant memory access or repeat of the memory access, then your code will be much hardware friendly, right? So I hope this answer your questions. Yeah, so I think that's answer Aditya's questions. Sorry, this Divyang questions. Uh, yeah, so to request to others, if you have any other question, please feel free to ask here. Any questions is encouraged. No questions is bad. Okay. And on the other hand, I'll have one more live sessions with you. So there are 3 live sessions in this course. So this is the second one. And Uh, so please utilize this opportunity to interact and discuss anything you want to learn or know about this course. I'll be happy to help you, right? So if no further questions, maybe I'll wait for another 4 or 5 minutes and then we'll conclude the session. Uh, Prepare well for the end semester. Do well in the course. There are internship opportunity through this course for the toppers. There are NPTEL pre-doc fellowship also there, where again it is kind of giving to the good performers of the course. So if you're looking for higher studies, try to get an internship in IIT Guwahati with me. or you want to come here for 1 year and with an NPTEL fellowship of 25,000. This is for graduated student, obviously, not for the BTech third year or fourth year students. I think that's a good platform so that you can actually see what is the things about research. Are you liking that kind of life? The kind of life we have here, my students, my PhD students, and then you can take a conscious decision whether you want to do higher studies or I no, higher study is not for me. I better I'll go to academic industry, right? So this is, I think NPTEL has created a very nice initiative uh, which effectively help uh, people who are not sure about whether they'll go for higher studies or not. They can actually come and explore the opportunity, right? Yeah. Where can we get the question for practice? I think there is no such uh, you can actually check the last 2 3 years question if it is available in NPTEL and some questions. I think it is available. Otherwise, the assignments questions what we are giving, you can actually play with the similar questions. That will help a lot, right? For example, if I given an assignment on scheduling, you take another graph, you draw your own DAG and you try to solve, right? So this is the kind of thing you can do, right? As such, there is no question bank, right? So assignments are the good pointers, right? What kind of questions you're going to get in in the exam. Okay. Okay. So if there is no further questions, at 6:50 we'll conclude another 4 minutes from now. But I'll be happy if you have any questions, I'll continue the session. So we'll conclude in a couple of minutes. If you have any question, please put it here. Otherwise, I'll strongly encourage you again to see the demo of the tool, install the tool, uh, run few test cases on your own, then only you learn the course properly, right? So that is my request to all of you. Just don't go by the theory and all. If you want to use the tool for your research, higher studies, or BTPMTP project, you have to install the tool. You have to run the tool on your own and see how to apply the optimization to get a better hardware. Just generating a hardware is not the solution, right? Generate an efficient hardware is the solution, is the objective. So if you do not understand how to make a efficient hardware through HLS, then the kind of study that you're doing here is not complete, right? So please do that, and the demo that I have set will help you. Okay, I think I have answered all the questions you have. Wish you all the best. I'll wait for another minutes probably, and then I'll conclude the session. Anyway, I'll come back for the third session. So if you have any other questions, uh, I'll be available for the third session. And feel free to put your questions in the group discussion, the course forum. My TAs usually answer all questions within 24 hours. And any doubt about the assignments, any doubt about the theory that have been taught in the class or the videos, uh, please feel free to put questions, whatever you have, and we'll be happy to clarify any doubt you have in the course or the assignments, right? Okay, thank you very much for joining.